A huge thanks to Brian for sponsoring this video. Good morning, fellow mathematicians. Welcome back to another video. I gotta tell you the truth. Gotta be honest with you, at least once in your life, my son. It's actually not morning. It's in the evening. Yeah, it's nearly 7:30 in the evening. If you don't know what that is, by the way, this wasn't even supposed to be something sponsored like, but this right here is the incredibly unrigorous engineering watch. We got this over on stemage.com. Check it out if you haven't gotten yourself one of these already. Yeah, today something chill once again. What we have given is x plus 1 over x is equal to 2. And we want to find out what the value of x to the 5th power plus 1 over x to the 5th power is. Spoilers, it's gotta be 69. Who would have thought? But how do you calculate something like this? This is what we want to find out today, and I hope you are going to enjoy the video. By the way, if you're not fluent in the language of algebra at the moment, why not check out some courses over on Brilliant? More information at the end of the video, but it's going to give you a good refresher in terms of algebra, multiplication and the like, if you check it out. So now we are going to dive right in. So x plus 1 over x is equal to 2. How could you go about finding out what x to the 5th power plus 1 over x to the 5th power is? At first I would like to take a look at exponents in general. If you have something a to the n plus mth power, by the exponentiation rules you can break this up into a to the nth power times a to the mth power. Meaning, okay, just to keep the long story short, if you have x to the 5th power, what you can do is you can turn this into x to the, for example, 2 plus 3th power or 1 plus 4th power or the like. And then you can break this up into the multiplication of x squared times x cubed. Now this is going to help us later in the game, this tiny little thought here. The first thing that we are going to do is we are going to square our original equation. Hence, we are going to get some factor with x squared in it. We are going to repeat this process basically up until we get to some kind of x to the 5th power. Now, if you were to square both sides of this first equation, we're going to get on the left hand side x plus 1 over x, but the whole thing squared is equal to 2 squared, which is nothing other than 4. Now, what about the left-hand side? Well, this is just a binomial theorem giving us overall, and this is where the magic is going to happen basically. So this is going to give us x squared plus 1 over x squared plus 2 times the product of these two. So 2 times x times 1 over x. And all of this is still equal to 4. Now, cool thing is, x times 1 over x, well, this is going to cancel out, just giving us 2 here. I mean, this right here is a constant, giving us something of the form x squared plus 1 over x squared. We're getting closer to x to the 5th power plus 1 over x to the 5th power. Let us subtract 2 on both sides, giving us that x squared plus 1 over x squared is nothing other than 2. Okay, it's the same value as the original equation. Let us continue with this thought. If you have our original equation squared basically, especially the left hand side, this is just multiplying x plus 1 over x with itself. So why not multiply x squared plus 1 over x squared with x plus 1 over x, and then let's see what is going to happen. Since we know what x plus 1 over x is, this is nothing other than 2, so we know the value of this. And also maybe this cancellation madness is going to once again pop up in the process. So what about multiplying x squared plus 1 over x squared with x plus 1 over x? Well, if we take a look, so 2 was the value of x squared plus 1 over x squared times, and the value of x plus 1 over x is equal to 2 once again. So this is going to give us 4 in the process. Now what about the left hand side? Well, we are just going to multiply everything out. It's as easy as this. So 4 is hence equal to x times x squared is going to give us x cubed. Same thing with the 1 over x parts, giving us plus 1 over x to the 3rd power. Now, then we are going to get x times 1 over x squared, so plus x times 1 over x squared, and also the other way around, 1 over x times x squared, plus x squared times 1 over x. Now, if we take a look at this last part here. So this first part is very, very good. This is something of the form x cubed plus 1 over x cubed. So we are getting even closer to what we have up here. But this part right here, this is actually pretty fabulous. X times 1 over x squared is going to give us 1 over x. And here x squared times 1 over x is going to give us just x. Oh, x plus 1 over x. We know what this is. This is equal to 2. Meaning we have now the equation 4 is equal to x cubed plus 1 over x cubed plus 2. Meaning if we were to subtract 2 on both sides, we are going to get that x cubed plus 1 over x cubed is actually equal to 2. Okay, now we could continue this process multiplying x plus 1 over x to the whole thing 2 more times. And then we are going to just solve for this part right here with the exponents. But by following our original thought, what we could also do is we could multiply these two equations together, giving us x to the 5th power and, by this logic, also 1 over x to the 5th power in the process. So let us do this. So what about x cubed plus 1 over x cubed times x squared plus 1 over x squared multiplied together. So we know what the values of these are individually, 2 and 2. So meaning 2 times 2 is going to give us 4 overall. Now we can start multiplying everything out. Meaning 4 is equal to. Now we are going to get, just like here, x to the 5th power plus 1 over x to the 5th power. And also, what else are we going to get? X squared times 1 over x cubed. X squared times 1 over x cubed. Oh, we know what this is. This is going to give us 1 over x. Let me take a wild guess here. Next summand is going to be x cubed times 1 over x squared. Meaning what we're going to get here once again is x plus 1 over x. But we know what this is. This is nothing other than 2. Meaning by subtracting 2 on both sides, we are going to get the very, very boring solution to this problem. That x to the 5th power plus 1 over x to the 5th power is actually equal to 2. Now the cool thing about this is that this is actually some kind of fixed point, you could say, okay? For all of these powers that you are going to get here, you can probably show this by induction. You're going to get that this is going to be equal to 2. At least if we start with our original equation being equal to 2. We can actually just set this equation equal to n, and then we are going to see what happens. Okay, so if we have x plus 1 over x being equal to n. Now what about our squaring? Okay, if we were to now square this, not much is going to change in the logic, except for, okay, our 2 was squared here to 4, meaning we are going to get n squared, and then we are going to subtract 2 from this whole thing. So we are going to get, by just solving everything once again, that x squared plus 1 over x squared is equal to n squared minus 2. And now we can continue with this process. What else have we found out? Now, if we were to multiply our x squared plus 1 over x squared with x plus 1 over x. That's the next thing that we are going to do. So x squared plus 1 over x squared times x plus 1 over x. We know that this right here is nothing other than n by the original equation, meaning also this right here is n squared minus 2. We are going to get n to the 3rd power minus 2n. And if we were to multiply everything out, we know that this right here is going to result in x cubed plus 1 over x cubed plus x plus 1 over x. But this right here is nothing other than n. Meaning if we were to subtract 1 more n on both sides, we are going to get that x cubed plus 1 over x cubed is actually nothing other than n to the 3rd power minus 3n. And well, now we can just multiply these two together to get our final equation basically, or our final solution just in a generalized fashion. What we also find out, or found out before, is that if we multiply x cubed plus 1 over x cubed with x squared plus 1 over x squared, what we're going to get is, on the one hand, the multiplication of these two, obviously. So we are going to get n squared minus 2. And this thing right here, we can factor out a common factor of n. So n times, then we're going to get n squared minus 3. So here's a nice pattern that is going to pop up. And you can probably generalize this even more to some arbitrary power instead of x to the 5th power plus 1 over x to the 5th power. I leave this up to you to solve as an exercise to the viewer. And we also know what this right here is going to evaluate to, namely x to the 5th power plus 1 over x to the 5th power plus x plus 1 over x. And we know that this right here is once again equal to n. So if we were to subtract n on both sides, we are going to get that x to the 5th power plus 1 over x to the 5th power is n times n squared minus 2 times n squared minus 3 minus n. But we have n as a common factor, so the final formula in a generalized fashion is n times n squared minus 2 times n squared minus 3 minus 1. Now you can plug any all initial value in and see if you can find out the solution by doing a bit of calculation. For example, what about n being equal to 1? What is going to happen here? I'm actually wondering, if you plug in 1, we are going to get, for n equal to 1, we are going to get 1 minus 2 is negative 1. Then we are going to get negative 2, so this is positive 2. Minus 1 is 1. 1 times 1 is 1. Okay, we are going to get that this right here is going to be equal to 1. Now what about n being equal to 3? Okay, haven't tried out any values, so let's just see. N being equal to 3, so this right here is going to give us 9 minus 2 is 7. Then we are going to get 9 minus 3 is 6. So this right here is going to give us the meaning of life. 42 minus 1 is going to give us 41 times, and we said 3, right? Yeah, meaning this is 123. And 123 is not a prime number, it's divisible by 3. Yeah. And so on and so forth. Try to find out a few values. You can also use fractional values, obviously, or square roots, okay, as the starting value. Just try to play around with this formula a tiny bit, and maybe you can find even more of a generalization in the process. And this concludes today's video. And if you did enjoy what you have seen today, if you're interested in more algebra, calculus, and all of the like, then I invite you to try out the contents of today's sponsor, Brain, who are kind enough to sponsor yet another video here on this channel. Man, this problem was hella refreshing. I really liked this one. I don't know why. It was easy. The answer was kind of obvious even after the first iteration, but it was still fun to solve through it. And if you're a sucker for solving algebraic equation, and maybe you also want to see the intuitive nature behind all of these equations, especially polynomials and their graphs in coordinate systems, then the content of today's sponsor could be the perfect fit for you. Brain is an online learning platform and app with over 60 interactive courses in all topics STEM, be it mathematics, physics, chemistry. No matter what it is you're seeking after, Brain definitely got something up the sleeve for you. And if you are one of the people who learns by taking a look at something graphically, which is going to give you an intuitive understanding of the problems at hand, then Brain is definitely a platform that you could be interested in. Interactive courses means that you are going to have, for example, a parabola given, or maybe an algebraic structure, be it just the multiplication of two natural numbers. This multiplication can be interpreted as taking two bunches of things and multiplying these together, taking a look at the product of the two in general. 2 times 3, 2 rows of blocks times 3 rows of blocks, giving you 6 in the process. And this is what Brain does all the time. Next to their amazing exercises, which start off with a simple topic, getting gradually harder, giving you a better understanding of the topic at hand, they also use a lot of these interactive experiences and also graphics to give you a better understanding. And if this feels like it's something for you, if you think that this could benefit your learning experience in some kind of way, then definitely make sure to check out the link at the top of the description, brain.org/flammable math. With it, you're going to get 20% of an annual premium subscription if you really make use of the link. But if you're not sure yet if this could be something for you, then why not just try it out, big portion at least for free by using the link down there. So definitely make sure to check it out and support the channel this way. And yeah, this concludes today's video. Appreciate ya. Ciao.